Assalamualaikum, my name is Siti Norkanisha and I'm going to explain about microbes living in high temperature environments. Usually these microbes are referred as thermophiles and hyperthermophiles. Thermo means heat, philes means loving, so they are basically heat-loving microbes. I will explain in detail about thermophiles and hyperthermophiles in the next slide. Thermophiles are microorganisms with optimal growth temperatures of higher than 60 degrees Celsius. For example, Geobacillus Thermophiles. Hyperthermophiles are extreme thermophiles with growth optimal temperatures of higher than 80 degrees Celsius. For example, Pyrolobus fumari and Pyrococcus furiosus. Habitat of thermophiles and hyperthermophiles. Well, they can be found in terrestrial hot springs, volcanic sites, and deep-sea hydrothermal vents. Their characteristics are they grow in huge colonies called mats that form confused combs on the sides of the hot spring. They derive their energy from various chemicals and metals like hydrogen reduced sulfur compound, so many of them adapted to highly acid conditions due to production of sulfuric acid. And lastly, majority from the deep sea are came out of the trough. Pyrococcus furiosus is an aquatic anaerobic hyperthermophile archaea, so let's talk about how it adapts to such high temperature environments. First, it has thermostable and efficient translational machinery that able to synthesize functional protein at high temperature. Why? Because its tRNA and rRNA have high GC contents, which make them more stable. Upregulation of ribosomal proteins are required for functional protein synthesis against heat stress. To overcome heat stress, LSU ribosomal proteins L10E, L12A, and L7AE are more abundant at 90 degrees Celsius compared to 70 degrees Celsius. Next, Pyrococcus furiosus express HSP60, known as chaperonin. Chaperonin possesses chaperone activity, which assists protein folding and prevent protein aggregation. Chaperonin helps to refold denatured proteins, so denatured proteins is converted into active form, which make the protein becomes functional. This heat shock response by chaperonin protect against cellular damage induced by heat stress. Next, in Pyrococcus furiosus, there is presence of monovalent salts that enhance the stability of nucleic acids. Monovalent salts KCl protect DNA against thermal denaturation by shielding the negative charges of the phosphate groups in the backbone of DNA. This provides thermal stability to the nucleic acids. Besides that, KCl also protects the DNA against thermodegradation. Thermodegradation is heat-induced DNA cleavage and depurination.